Welcome back to my 3D printer build log. Today I'll mount the bed, fix the arm joints, add the bed height sensor and perform yet another test run. The print bed finally arrived along with the silicone heater, the print surface and some mounting material. I'll use these standard aluminium corner pieces to mount the bed, but before that I'll have to glue the silicone heater to the bed because the mounting screws actually reach through holes in the heater mat. I'm not yet mounting the actual print surface, that will have to wait until I'm confident I won't be crashing the nozzle into it. Now for the mounting brackets. I'm using 3 sets of 2 corner pieces mounted at an angle of 90 degrees. First I have to get rid of one of these alignment dimples on each of the pieces. A simple file takes care of that in no time, and I've read somewhere that wetting the file with ethanol makes it easier to remove the aluminium from the file afterwards. Seems to work for me. Now I can screw the 2 corner pieces together. The remaining dimples on each side prevent the pieces from rotating against each other, which is really convenient. This is the mounting set that came with the build plate. I'm screwing into the brackets before mounting them on the frame because the screws will be awkward to reach later on. Now I can mount the brackets to the frame. It's actually not that easy to get the positions right, but watching me fiddling around to get this adjusted is rather boring, so let's move on. And here is the print bed. For some reasons, the holes are not only countersunk but also tapped. Anyway, if the brackets are positioned correctly, it's easy to screw it in place. Now for the arm joints. My earlier approach of pressing UHMW discs into the magnets turned out to be a bad idea, since it allowed for lots of play in the joints. So after removing the discs, I placed 3 narrow strips of UHMW tape into each of the magnets. Pro tip, use non-magnetic pincers for this. Holding the strips in place with a steel ball, I bent and cut the overhanging pieces flush with the magnet side. And here are the upgraded joints, much better. Next up, the mini differential infrared height sensor by David Crocker. I've printed a small enclosure for this sensor, and in order for it to fit, I've already replaced the straight connectors with angled ones. 2 screws will hold the board in place and 2 magnets in the tabs will hold the sensor to the effector, making it easily swappable. The magnets are pressed into place and the sensor board has some guide rails inside the enclosure to prevent it from tilting to an angle. Now for another testing effector. I'm still waiting for some components for a real 3D printing effector setup, but in the meantime I've printed this effector that holds a pen which can be fixed with a screw. As usual, it requires 6 steel balls glued to the underside. Let's skip the gluing, tapping and mounting and move on to the next interesting bit. Here is how the height sensor is fitted to the effector. There are 2 iron screws that the magnets hold onto and that can be used for fine-tuning. Another thing I didn't record was me fiddling with the configuration and getting the bed leveled. It wasn't particularly hard, but it isn't particularly entertaining to watch either. Now we've got a pen mounted in the effector, let's see what we can do with this. The following part of the video is not sped up in any way so that you can get a good impression of the actual movement speed. I've also tried to capture the sound of the printer running, so let's lower the background music volume a bit. I'm using the retraction vertical lift setting in my slicer to have the printer lift the pen off the paper between the individual lines. And that's it for today, leaving you with the seasonal impression and the knowledge that this video should have been uploaded 2 weeks earlier. Whatever. If you have any comments, please leave them below, and if you liked the video, please give it a thumbs up. And please subscribe to get notified of new videos. See you later.